So now let's do its displacement. So our displacement is, so we can calculate displacement equals ut plus half at squared. Okay, so if we revise that, our u is 29.4. Let me put that in yellow. So 29.4 t. And because our acceleration is negative, and we can already halve that, we'll take away 4.9 t squared away from that. Okay, let's do the math. If at time equals 0, this will all be 0, because whenever you multiply 0 by 0 by whatever number, you're going to get 0. So, and that's pretty logical. So our displacement is going to be 0 at time equals 0. At time equals 1, you're going to have 29.4. 1 squared is 1. So 29.4, take away 4.9. Okay. So 29.4 take away 4.9 will be, so at time equals 1, the displacement is going to go positive 24.5 meters. Okay, so at time equals 2, it's going to change now. So 29.4 times 2, okay, which is 58.8, take away 4.9 times 4, because 2 2's are squared, so take away 4.9 times 4, it's going to be at 39.2 meters. At time equals 3, 29.4 times 3, and then take away 4.9 multiplied by 9, because 3 squared is 9. It's going to be 44.1 meters. So now let's keep going. At at time equals 4, so 29.4 times 4 is going to be 117.6. So this one is, okay, 29.4 times 4, and take away 4.9 times 16, because 4 4s is 16. And we should notice something. It is 39.2. I think you can see a pattern already forming here. So if we do the rest of the numbers, you can actually fill in these quite logically, because this one's going to be 24.5 and this is going to be 0. Okay, so you notice here, and quite logically, that it'll get to a point in time where it'll be at 0, and then it'll get to a point where it'll have 0 velocity, so it'll stop, it'll get to a maximum height, and it'll come back down in the same motion, but you'll see that the displacement will be getting less and less and less until it comes back to its origin. So if we graph that, if we do a displacement, okay, so we have a displacement by time. We'll do time 1, 2, 3, 4, 5, 6, and our highest displacement was about 44.1, wasn't it? So let's say that is 50, 15, 40, 30, 20, 10. 40, 30, 20, 10. And this is going to be our displacement in meters. Okay, so at time equals 1, the displacement was 0. At time equals 0, the displacement was 0. At time equals 1, the displacement was 24.5. So let's put that in. 24.5, so it's going to be around about there. At time equals 2, the displacement is 39.2, so it's going to be around about here. At time equals 3, it's at 44.1, so it's going to be around about here. Time equals 4, it's at this point. Time equals 5, it's at this point. Time equals 6, it's at this point. So if you notice the path of it in, okay, it's a parabola. So there's a couple of things that you should be able to notice in graphing it, and there's a couple of really important occurrences that we can actually deduce from this in order to actually answer our question. In order to answer how long does the footy take to come back down. We answered that it takes 6 seconds for it to come back down, doing it graphically, sorry. And how fast is it going when it comes back to buddy? Okay, we found out that it's going at negative 29.4 meters per second when it comes back down to buddy. And how high did he kick it? And we found out that he kicked it at a maximum of 44.1 meters above. Now, there's a couple of bits of data that's actually quite important for you guys to have a look at. I know this video is going on really, really long, but let's do this very, very final bit of data, and it's actually quite important. Sorry for such a long video. Let's have a look at our table and also at our graphs. We can find out here that at half the time, so let's just put a little notation, at time equals half, meaning at half the time it actually takes for it to do its motion, its entire motion, at the halfway mark, the displacement is going to be at its maximum and its velocity is going to be at 0. So we can actually use that bit of data to figure out a couple of things. Okay, one, you can use that to figure out the full time. Okay, so let's have a look at one of our equations here. V equals u plus at to figure out for our t. Okay, so we know that at halfway through the motion, okay, v equals u plus at. At halfway through our motion, okay, the final velocity is going to be 0. Okay, and let's use this one. It's going at 29.4 meters per second. So we take that away from 9.8 t, okay, because it's going to slow down 9.8 meters for every second. So if we bring this factor over to the other side, so if we say that negative 29.4 equals negative 9.8 t, we can solve for t. T just equals negative 29.4 over negative 9.8, which is, if you do the calculation, should be 3. Now remember that this is the halfway mark. Okay, so t half. It's halfway through its motion. So in order to get the full motion, you just double that. So the full motion time equals 6. So we did that numerically, algebraically. Now in terms of the displacement, the other thing that we know, that at this velocity as well, we know that the displacement is going to be at its maximum. So at this time, so we've figured out the time. Let's do a different color. And let's go underneath here. Okay, we know at that point in time, being 3 seconds, the displacement, as we see here, at that particular time at halfway through its motion, the displacement is going to be at its maximum. So it was ut plus half at squared. We've just figured it out, which equals 29 point, oops, 29, oh, missed the curve, sorry, 29.4 times 3 plus half of negative 9.8 times 3 squared. So it actually should end up about 44.1 meters at its maximum. Okay, last bit of information. I'm sorry, it's the last bit, very last bit. Very last bit is that you've got to make sure that you know that you're keeping consistent with all your units and your coordinate system. Okay, so you need to make sure that that 9.8 always stays a negative 9.8, so that it will stay consistent the whole way through, and that your units at the end and your direction is going to be in the right direction, in the right magnitude. So hopefully that was really helpful. You should be able to do it now in one of 3 ways. You can do it in a table, you can solve it for a table, you can solve it graphically, you can also solve it using our equations. So hopefully that was helpful, and I'm sorry for the really ridiculously long video, and I'll talk to you guys about the next type of motion in the next video.